Explore the topic of rock strata, fossils, and the flood. So where should we begin? With none other than Jesus Christ, the Creator, because he spoke of the days of Noah as a literal historical period in which a real man called Noah lived. And he also spoke of how Noah entered the ark and the flood came and took them all away. Notice that, all away. He spoke of it as a real, literal history in which there was an ark and a life-destroying global flood. Now, if Jesus Christ taught that and believed that, then you and I should believe that as well. And when he spoke of the flood coming and taking them all away, in Matthew 24, he was likening it to the time when he would come the second time, when the Son of Man comes. And so we all believe that the second coming of Jesus will be global. So he compares it to the flood, so it had to be a global event too, a literal historical event. Well, when we look at the Earth's rock strata, we find that they only look old. It's important to remember this. They only look old because of the assumptions used to interpret what we see and measure. We don't have rock layers with labels on them saying, I'm hundreds of millions of years old. No, the scientists interpret the rock layers and impose those ages on them. And the underlying assumption is that the present observable geological processes and their rates, that's important to notice, and their rates, are all that is required to explain how the Earth's rock strata formed. Now, if you take that assumption, because today's geological processes are exceedingly slow, we all agree on that, but with very occasional spurts when there's a volcanic eruption or a regional flood, the Earth's rock strata, using that assumption, would have appeared to have taken billions of years to form. But it's all based on that one assumption, which isn't a biblical assumption. We have to ask ourselves, is the present the key to the past? After all, that's the mantra of the evolutionary geologists who say that we look at present-day processes and extrapolate them back to the past. So we should ask the question, is the present really the key to the past? Well, another question that helps focus in on what I mean here, do we see vast fossil beds forming today? I mean, when was the last time you saw all the dead fish on the bottom of the ocean waiting to be fossilized? Well, the answer, of course, is obvious. We don't see vast fossil beds forming today. Therefore, the present cannot be the key to the past. In fact, the Bible says the past is the key to understanding the present. So, among geologists, there's increasing recognition that most fossil beds and rock layers required catastrophic geological processes to form. And so what happened in the past, the Bible says, the flood, is a key to understanding why we have the rock layers and the fossils today. And so because there's increasing recognition of catastrophic geologic processes, then a catastrophic flood, global flood, is a viable explanation for explaining the Earth's rock layers and fossils. Well, let's go back to our textbook and read the biblical account of the flood so we can focus in on the details and what those implications are from what we read. First of all, we read all the fountains of the great deep were broken up. The windows or floodgates of heaven were opened. That's how the flood began. And the rain was on the earth for 40 days and 40 nights. Imagine that, global torrential rainfall for 40 days and 40 nights, with fountains spewing water from inside the earth and water cascading down from those clouds from the rainfall. And that's why we read next that the waters prevailed exceedingly upon the earth, and all the high hills that were under the whole heaven were covered, and the mountains were covered. Notice that, all, every, whole. The emphasis on those words. Deliberately, we read all flesh died that moved upon the earth, not some flesh, all, and every living substance was destroyed which was upon the face of the ground. Do you think the Holy Spirit could have not made it any clearer? All, every. And remember, Jesus said the flood was like it's going to be when he comes again, a global event when he comes again. This is a description of a global event here in Genesis chapter 7. So, we have a question now to ask ourselves. Remember, when Jesus was asked a question, sometimes he asked a question in return. He answered a question with a question. Why is that? Well, it puts the onus of proof on the skeptic who's asking the question. Have you ever thought about it like that? Well, here's the question we want to pose today. What evidence of a catastrophic flood would we look for? If the Bible description, the biblical description is accurate depiction of a global catastrophic event, we ought to find evidence of that today, and we do. And so it's obvious we should ask the question, what evidence of a catastrophic flood will we look for today? That's a good question to ask a skeptic. People who come to you and say, oh, there's no evidence for the flood. You want to say to them, first of all, let's read what the Bible says about that event. Now, based on what we read, what kind of evidence would you expect to find for a catastrophic global flood described here in the book of Genesis? So what I want to do today is focus on 6 easy-to-understand evidences that answer this question. So, here we go. First of all, we would expect to find evidence that the ocean waters flooded over the continents. We'd expect to find evidence of rapid burial of creatures and plants. Every living substance perished, swept away by those flood waters. We'd expect to find billions of dead things buried in rock layers, laid down by water all over the earth. We'd expect to find widespread, rapidly deposited rock layers or strata. That's right, as the ocean waters flooded over the continents carrying sediments, they would lay down layers right across the continents. And we'd expect those sediments to be carried a long distances, right across continents, even all the way around the world. That's the kind of evidence we'd look for. And we'd expect to find that the layers were deposited one after the other with either rapid or no erosion between them. Not millions of years, no, between the layers, one layer after the other, and therefore we'd expect to find evidence of a rapid succession of rock layers, one layer after the other in rapid succession during the flood year. After all, it was a year, that's a long time for water to be catastrophically moving around the earth on a global scale. Well, let's look at this in detail now. What evidence do we actually find in the geologic record? Well, evidence number 1, ocean waters flooded over the continents. The evidence we find is that we find marine fossils in rock layers covering the continents. Now, that might seem pretty obvious, because here we are in northern Kentucky, underneath the Creation Museum, we have marine fossils. That's right. We're nearly 1,000 feet above sea level, 500 miles from the nearest ocean. And these are creatures that lived in the ocean, now buried up on the continent. How would they get buried up on the continent? If the ocean waters flooded over the continents. And that's exactly what we find. And most geologists recognise these are marine fossils, but they don't put the 2 and 2 together to say that it was a global catastrophic flood. We'd also expect to find rapid burial of creatures and plants. So we'd expect to find evidence of extensive fossil graveyards. That's where we find a lot of fossils buried together, a graveyard. And we'd expect them to be exquisitely preserved because they have been buried rapidly. Well, let's unpack those evidences with some examples. First of all, let's go to the Grand Canyon. Now, there are other places where you've got bigger canyons, wider canyons, deeper canyons, longer canyons. What's so special about the Grand Canyon in the southwestern United States? Well, we have exposed to view there the rock layers because it's a desert environment, so the biology doesn't cover up the geology. But also, we see a transect of layers, like a slice through the earth, showing the layers that happened during the flood. The complete geological record with a few gaps here and there, but nonetheless we can see the full span of Earth history on display before our eyes. Now, in every one of these layers that you can see I have arrowed here, every one of those layers contain marine fossils. The top of the Grand Canyon, the south rim, is over 7,000 feet above sea level. The North Rim is over 8,000 feet above sea level. And yet, in these layers, we have marine fossils. The only way we can explain that is the ocean waters flooding over the North American continent, bringing the marine creatures from the oceans where they lived in the pre-flood world and burying them up here on the continent. Well, let's look at one of these layers. Halfway down the walls of the Grand Canyon, we have a layer called the Red Wall Limestone. Now, you all know what limestone is. It's lime turned to stone. That's pretty easy to understand. But there's more than one limestone layer in the Grand Canyon, so they have to give them a second name, a prefix, to distinguish one from the other. And this one is called the Red Wall Limestone. Well, can you guess why they call it the Red Wall Limestone? Here it is, on view from the south rim of the canyon. That's right. Geologists are pretty simple, you see. Red wall. You see the red cliff? So it's easy to remember. The Red Wall Limestone is that red cliff or red wall you see halfway down into the Grand Canyon. And here we can also see the same Red Wall Limestone from the Colorado River when you float down there or paddle down there, down along the Colorado River. Well, the Red Wall Limestone is a graveyard full of marine fossils. Here we can see two examples. On the left, you can see a crinoid or sea lily. It's not a plant, it's an animal. And on the right, you see a bryozoan, or a lace coral. A little lacework pattern there preserved in the rocks. And that's a limestone. A crinoid or sea lily and a bryozoan or lace coral buried together. And many of these fossils are broken and jumbled. What does that indicate? Catastrophic burial. Floodwaters ripping these materials around as they are carried up onto the continent. So we can see on the left the crinoids have all been broken apart. These little columns that are stacked on top of one another, these discs to make the column or the stalk, has been ripped apart. And on the right you can see corals that have been deposited and buried at all different angles. That's not the way they lived. They all lived at the same angle, but now they've been buried in a jumbled mass. And this mass is between 500 and 800 feet thick. That's a lot of fossils, billions of dead things, just in this one Red Wall Limestone layer. Well, there are multiple parts of the Red Wall Limestone, and near the bottom of that sequence of layers that make up the Red Wall Limestone, we find a very interesting fossil. It's called a Nautiloid fossil. Now, you're all familiar with the paper nautilus today that's got a coiled shell. Well, these were straight-shelled nautiluses. They had a shell that you can see there, fossilised, that was like a cigar shape. And out of the head end, you had the head like a squid with tentacles. And these creatures used to move along in the water currents at different depths. And of course, when they were born, they were very small. And as they grew, they got bigger and bigger and bigger and bigger. And the nautiloid fossils we find here in the Grand Canyon are between 1 and 6 feet long. That's pretty huge, 6 feet, something like that. The little ones must be the baby ones, juveniles. The middle-sized ones must be the parents. And the long ones that grew all their lives must be the grandparents. And there's a mixture of these fossil sizes in this layer, indicating that this was a living population that got buried together. Now, they are found in a bed that's 7 feet thick, right down near the bottom of the Red Wall Limestone. It's called the Whitmore Nautiloid bed. And here we see a map of the canyon, and all of those dots and stars indicate places where these nautiloid fossils have been found from the eastern extremities of the Grand Canyon all the way through the Grand Canyon, way out past the suburbs of Las Vegas to the west and up into Utah to the north. In fact, it's almost an area of something of the order of almost 12,000 square miles. In fact, here's the statistics for you. Because we find them, the density we find them in, we find that we can add up with a calculation that there must have been billions of these nautiloids fossilized and buried and fossilized in this 7-foot thick bed with other marine creatures, crinoids or coelies, corals, brachiopods or lamp shells, gastropods and bryozoans or lace corals. And this bed stretches at least 180 miles from one end of the canyon to the other and beyond, and covers an area of at least 12,600 square miles, almost 12,000 square miles. That's a ginormous area, and you can understand if we find these nautiloid fossils at a density of 2 or more for every 3 square yards, or 2 square metres, 2 or more for every square metre or square yard, then we're talking about billions of them over that area. You can calculate them all. And because of the different sizes, it had to be a living population that was buried. It's a mass kill. All of these creatures had to be buried all at once. 24 cubic miles is estimated of lime sand and silt was deposited by a hyper-concentrated sediment gravity flow. That's a fancy name for a debris flow. Sediment and water all mixed up in a thick soup. And it was travelling at 11 miles per hour. 11 miles per hour. That might seem slow, but at that pace, the 12,000 square miles with billions of nautiloids would have all happened in just a few hours. And, we notice, and here's a diagram of what this debris flow might have been like, sometimes you get turbulence. Most of the nautiloids are buried fossilised in the same direction, the direction that the debris flow was going in. But some of them have been buried vertically. 6-foot ones buried vertically. Now, if it was slow and gradual burial of a 6-foot nautiloid, it would have taken thousands of years. How would he have stood up like that for thousands of years, waiting to be buried and fossilised? No. It was a chaotic surge. Many of them were buried flat like this, in the direction of the flow. Some were buried upright like that. So, here is evidence of rapid burial of creatures and plants in these extensive fossil graveyards, and we've cited this example, described it, the nautiloid bed with other marine fossils in the Red Wall Limestone of the Grand Canyon. But there's many other examples from all around the globe. Let's go to France, where we find hundreds of thousands of marine creatures buried with amphibians, spiders, scorpions, millipedes, insects and reptiles. Notice that? A mixture of land-dwelling and marine creatures buried up on the land. Well, marine creatures and land creatures don't live together, and they're up on the continents where the land creatures, they're buried up on the continent where the land creatures lived. So that means the ocean waters had to carry the marine creatures from the ocean as the continent was flooded and bury the marine creatures with the land-dwelling creatures. See how easy it is to make the observations and deduce how the evidence supports a catastrophic global flood. Here's another example. In Florissant, Colorado, not far from Colorado Springs, a wide variety of insects, freshwater mollusks, fish, birds. I mean, how do you bury a bird slowly? And several hundred plant species, including nuts and blossoms, are all buried together. Again, notice a mixture of creatures from a number of different environments all buried together. And let's look at some of these fossils. Here's one of the fish fossils from the Florissant beds of Colorado. And buried with a fish fossil, we find a fossil wasp. Look at the exquisite preservation of those wings. I mean, they're delicate. It had to be rapid burial to preserve a creature like that in all its beauty and form. And also these fossil blossoms. I mean, how do you preserve a flower or blossom unless you bury it immediately and preserve it instantly? Isn't that the kind of evidence you'd expect to find from a global catastrophic flood? Well, you can tell from my accent that I don't live around here. Well, I do, but I come from Australia, let me give you an Australian example in a minute after I tell you of another example here in the United States, in Wyoming. In the Green River Formation, we find alligator fish of many sizes, up to 7 feet long, and many varieties, from sunfish to deep sea bass to pickerel, herring, buried with birds, turtles, mammals, mollusks, crustaceans, and many varieties of insects and palm leaves. They're all buried together. And among the mammals are bats. I mean, how do you preserve a bat unless you bury it quickly? And notice a deep sea bass. Here we see marine creatures, freshwater creatures, and land creatures all buried together on a mass graveyard. Well, I promised you an Australian example. Here we go. Fossil Bluff at Wynyard in Tasmania. Tasmania is that little island state off the southeastern corner of Australia. And Fossil Bluff is at on the northern coastline. And here we find thousands of marine creatures, corals, bryozoans or lace corals, mollusks or clams, buried with a toothed whale and a marsupial possum. Well, here's the cliff. It's 80 foot high, it's limestone, but let's zoom in and look at some more details. See that? You've got pebbles with broken shells inside that limestone. Now, pebbles require fast-moving water, and that would break the shells, so we know it had to be fast-moving water to cause this mass burial in this limestone. And yet we find the remains of a toothed whale. Here's its skull on display at the museum in Hobart, the capital city of Tasmania. And alongside it was found the remains of a marsupial possum. Think about that for a moment. When was the last time you saw whales and possums living together? You know, in many museums they talk about the fossils buried together represent an environment. No. These two creatures don't live together. The whales come from the deep ocean, the marsupial possums on the land. How did they get buried together? Well, the marine creatures, including the whales from the deep ocean, had to be buried up on the land with this marsupial possum. And it had to be rapid to preserve all these creatures buried together like that. Well, two more examples just to make the point of how extensive these fossil graveyards are. First of all, the chalk beds of the United Kingdom, Europe, the USA and Australia, and we'll come back to that again in a moment, the global distribution of these chalk beds. But these chalk beds are made up of trillions of microscopic marine creatures, tiny little shells, plus larger coiled ammonite shells, and other marine creatures and other fossils we'll see in a moment are buried in these chalk beds. That's a ginormous global scale fossil graveyard. And think about the vegetation that makes up the world's coal beds. At least 7 trillion tonnes of vegetation. That's a lot of vegetation. That means that the forests that were on the continent, the supercontinent before the flood, had to be swept away and buried during this catastrophic global event. Here's the chalk beds on the English Channel coast. They're up to 1,000 feet thick in places. And here we can see the trillions of microscopic shells that make up the chalk beds. And in the chalk beds we find larger ammonite fossils. Now the rule of thumb is the largest fossil indicates the speed of the water that deposited the bed, okay? And so you don't look at the tiny little fossils, which are what the evolutionary geologists do. They think it was slow and gradual. No, you look at these large fossils that required a lot of material all at once to bury them. And here we see, you can see the pen for scale there. This was a very large ammonite fossil buried here in the chalk beds in the United Kingdom. Well, how do you form a fossil anyway? We've hinted at this and indicated it already, but consider this fish fossil. As I said before, when was the last time you saw all the dead fish on the bottom of the ocean waiting to be fossilised? Look at the preservation of this fish fossil. You can see the fins, the ribs, the tail, the eye sockets. Exquisite preservation. Well, I'll tell you how you preserve a fish fossil. While your pet goldfish isn't looking, back up a concrete wagon and dump the concrete on top of it. That's right. If you instantly bury it, you remove the possibility of scavengers or bacteria causing decay. So to preserve a fish fossil like this in such exquisite detail requires instant burial. What about this fossil here? This is a trilobite fossil. 3 lobes, trilobite. And you can see on the left-hand end, there's 2 knobs. That's the eyes of the trilobite. These guys lived on the bottom of the ocean floor, we believe. We don't see any alive today, or we don't know of any. But the lenses in those eyes were very, very complicated, incredibly complex, well designed. And yet these fossils appear suddenly in the fossil record fully formed and fully functioning. Why? Because they were buried. Buried catastrophically. They were all alive at the same time, but these guys were buried catastrophically. And beautifully preserved. That's the only way you'd be able to study the lens system of the trilobite eye today. Or what about this fossil here? You guess what that is? It's called Morsanites sprigii. Well, many people think that's a fossilised flower. It's not. It's a fossilised jellyfish. That's right, jellyfish. You know, the man that discovered these in outback South Australia concluded they all had to form in less than a day. Hundreds and hundreds of them over 400 square miles in less than a day. Why? Because a jellyfish washed up on the beach will get destroyed by the waves crashing on the beach and ripping it apart in the wind, and it would melt in the sun. You wouldn't get the details that are preserved in these fossils. That's right, over 400 square miles, thousands of these jellyfish fossils formed in less than a day. Or what about these 2 fish? The big guy didn't get time to finish his breakfast before the 2 of them were buried and fossilised. It had to be instant. 1 minute he's taking a bite, next minute buried and fossilised. Or this fossil here. That's an ichthyosaur 6 feet long, and she's a mother, because you can see I put an arrow there to point to the baby that's just been born. 1 minute, mother is giving birth to baby. A split second later, buried in tons of sand and mud. That's right. Remember, she's 6 feet long. If she sensed the danger, she could swim away. But no, she was buried instantly at the moment of giving birth to a baby. And there are many other examples like this. So, what other evidence do we find in the geologic record? We've covered 2 evidences. The ocean waters flooded over the continents, rapid burial of creatures and plants. Now let's go to evidence number 3. Widespread, rapidly deposited strata or rock layers. What evidence do we find? Rock layers that can be traced all the way across continents and between continents. That's right, as the ocean waters flooded across the continents carrying those sediments, they would be carried all the way across continents. And we'd expect to find physical features in these widespread rock layers that indicate they were rapidly deposited. Well, let's go back to the Grand Canyon and let's look at some examples of rock layers in the Grand Canyon. Now, we've already met the Red Wall Limestone. Now we're going to talk about the Coconino Sandstone and the Topeka Sandstone. That's right, they're at different levels and therefore they've got different names, different sandstone layers with different names. Well, let's look over the rim into the canyon from the south rim. Here we see the Coconino Sandstone. It's that white band near the top of the canyon walls. It's often called the bathtub ring of the canyon because it's that white soapy colour. And then we've got the Topeka Sandstone down the bottom. It's the last of the horizontal layers down there at the bottom of the canyon before you get into the inner gorge. And in between, we've met already the Red Wall Limestone. You know that red wall, that red cliff? That's the Red Wall Limestone. Well, The interesting thing is that these three layers, the Topeka Sandstone, Red Wall Limestone and Coconino Sandstone, belong to 5 megasequences, that is, large sequences of rock layers that can be traced right across North America. That's right, and beyond, in fact. Let me give you an example. The Topeka Sandstone is an easy one to see because it's at the bottom of the canyon, and we can see it there, that little cliff before you go into Inner Gorge, and underneath are the basement rocks. And at the bottom of the Topeka Sandstone, there's an erosion surface. The Topeka Sandstone sits on an erosion surface where everything else underneath was eroded off. Well, here we see it in the Grand Canyon. We can go all the way across to Chippewa Falls in Wisconsin, and we see exactly the same sandstone with exactly the same erosion surface underneath it and exactly the same crystalline basement rocks. Well, there's other places in between. As you go across the continent where you can see it. You can see it in Colorado, you can see it in Missouri, you can see it in Wyoming, and here we can see it in Wisconsin. In fact, the Topeka Sandstone and its equivalents, you can see there in yellow, have been traced right across the North American continent, up into Canada, across into Greenland, and in fact can be traced across northern Africa all the way to the Middle East, over there into Saudi Arabia. In fact, if you go to southern Israel, in the Timnah area, you can find exactly the same sandstone with exactly the same features, exactly the same erosion surface underneath, and exactly the same crystalline basement rocks. That's right across 2 continents, the same rock layer. Isn't that the sort of evidence you'd expect to find from a catastrophic global flood? Well, let's look at the Red Wall Limestone here in the Grand Canyon. We can see exactly the same limestone in other parts of the world. We can trace it from Arizona up into Wyoming, across to Tennessee and Pennsylvania in the Appalachians. But we also find it in Ireland and in England and also in the Himalayas, even with the same features and the same fossils. Here's the same limestone beds in the Burren in Ireland, the Republic of Ireland. And here's the same limestone beds near the top of the Himalayas. That's right, we find marine fossils near the top of the Himalayas. That means these mountains weren't there before the flood. These mountains are made up of flood-deposited layers that have been pushed up at the end of the flood to form the Himalayas. And let's look at the chalk beds. The chalk beds of southern England can be traced across to Northern Ireland and across Europe to Egypt and Turkey, but it's also been found in the Midwestern United States from Nebraska to Texas and in southern Western Australia with the same fossils in them and the same distinctive beds above and below them. That's right. The Red Wall Limestone we saw on 3 continents. We saw it in North America, across Europe, over to Asia. The chalk beds we find in Europe, we find them in North America, we find them in the Middle East, we find them in southern Western Australia. Here again we see the chalk beds on the English Channel coast. Here again we see the trillions of microscopic shellfish fossils, tiny little shells that are found in the chalk. It's a ginormous fossil graveyard. Here we see the same chalk beds in Israel. That's right, in Israel. By the way, at the bottom of this cliff is a brook, and from that brook, a shepherd boy picked up 5 smooth stones to go and slay a giant. And above him were these cliffs of the chalk beds that are a reminder of the flood. And the same chalk beds are found in the Midwestern United States. For example, the Niobrara chalk of Kansas that can be traced all the way across to Colorado. It could also be traced from Nebraska all the way down to Texas. Well, what's in the Niobrara chalk as well as these microscopic, tiny little microscopic shells? We find crinoid fossils in the Niobrara chalk. Beautifully preserved, intact, which meant that they had to be catastrophically buried. Or what about this fish? You can see how large it is. It's 10 feet long and it's got an undigested fish in its stomach. How could that have been a slow and gradual process? That means the chalk had to form rapidly, catastrophically. And included in the same Niobrara chalk, we find large pliosaurs, 12, 15 foot long, 10 to 12 foot wide turtles. We also find dinosaurs and bird fossils in the same chalk layers there in the Midwest of the United States. So we have air-dwelling, land-dwelling, and sea-dwelling creatures all buried together, large ones. It had to be catastrophic burial by chalk, which is a type of limestone, on a global scale, because these same chalk beds are found in southern Western Australia, in the Middle East, and right across Europe to England and Northern Ireland. Wow. Isn't that the kind of evidence you'd expect to find based on the Bible's description of the global catastrophic flood in the days of Noah? Absolutely. Well, before we leave this evidence, let's look at the Coconino Sandstone. The Coconino Sandstone, as I said before, is at the top of the Grand Canyon. It's a whitish cream layer. And, it can be traced all the way out through the western United States. It covers an area of at least 925 square miles. It can be traced from the Mexican border all the way to the Canadian border, all the way across to Southern California, all the way across to Kansas, North and South Dakota, Texas, Oklahoma. And it averages 315 feet thick. It's a huge. We're talking about at least 50,000 cubic miles of sand. That's a huge amount of sand to cover such a huge area. Now, within this large horizontal layer, we have these sloping lines that the geologists call crossbeds. What are they? They're the fossilized remains of dunes, sand dunes. Now, you're all familiar with desert sand dunes. The wind blows from the backside of the dune and over the top, and the sand grains fall to the front, and the front advances. Well, as you can see in this diagram, we can see the same thing underwater. That's right. Now, I don't recommend you do this, but if you were to jump off the Golden Gate Bridge and go to the bottom of the channel there, you would find these waves of sand being moved by the water current coming in and out through that channel. Same process. The water carries the sand grains from the backside of the dune or wave, and it drops over the front, so the wave advances. And what's happening, as you can see in this diagram, the sand grains are advancing, the front's advancing, so that it buries the backside of the dune in front of it as that dune advances. And so if you have a whole sequence of this, what you're going to get is layer upon layer of sand with these sloping crossbeds in them, which are the fossilized remains of the fronts of these sand waves or underwater sand dunes. Well, think about it. Air and water. Does it happen the same way? Well, essentially the flow is the same, but there's a very big difference. See that angle at the front of the bed, of the wave or dune? In a desert situation, you can get a bucket of dry sand and try this for yourself. You dump it on the ground, you can measure the angle of the slope. That angle is between 30 and 33 degrees. But underwater, that front slope is 25 degrees or less. So here we have an empirical test to work out whether the Coconino Sandstone was formed in air or underwater. And what do we find? We find the angle is always, in the Coconino Sandstone, 25 degrees or less. So it was underwater deposition. And we find that the Coconino Sandstone was deposited by multiple sheets of sand waves up to 60 feet high, being moved by water at 3 to 5 miles per hour, because we can figure out the height of those waves, and we can figure out from empirical evidence and experimentation how quickly the water had to move that sand. At that rate, the whole Coconino Sandstone bed would have been deposited in just a few days. Well, let's quickly look at an Australian example. Uluru or Ayers Rock in Central Australia. It's actually the tip of the iceberg. There's more of the same rock underneath in the surrounding desert sands and it's composed of sandstone layers that were once flat-lying, they were deposited flat-lying, but they're now tipped up at almost 80 degrees, and that shape has been eroded into it. And then the rest of the rock has been buried by the desert sands. And you can see the layering of the sandstone beds in that photograph, and in this photograph too. In fact, we can add up the thickness of all those layers. You can see exposed in the rock there, and you can look at what we find in the sand under the desert sands around, and it's calculated that these sandstone layers are up to 18 to 20,000 feet thick. That's a huge amount of sand. And we can study the sand grains to work out the closest source from which those sand grains would have been eroded. And we find out that the sand grains had to be eroded and transported at least 60 miles. What else do we learn under the microscope? Well, we find that the grains of sand are jagged and they're different sizes. Let me explain what the significance of this is. You ever done an experiment where you get a glass jar, you get sand and mud and water, put a lid on it, shake it up and let it settle? That's right. The coarser sand particles will settle first because they're heavier, and then the lighter, smaller mud particles will less. So the different sizes will be separated. So with time, you get separation of the particles. Notice here the particles are all different sizes, buried together, which means there was no time for sorting them out into layers with different sizes, grain sizes. And notice the grains are jagged. What do you notice when you look at, well, rivers and creeks today? The rocks you find there are often smooth because they've rolled down the bed of the river. They've had time to be smoothed off and polished. But these, in this sandstone, the grains are still jagged. They didn't have enough time to get rounded. The process was so rapid. And what do we find also? We find a mineral called feldspar. It's fresh, in fact. Now, feldspar comes from granites and other rocks like that, and it weathers very rapidly. It's softer than normal sand grains, and so for it to be preserved fresh in this sandstone at Ayers Rock or Uluru indicates it had to be buried rapidly. So we've got all three indications of rapid transport and rapid burial. Well, putting all that together, what do we conclude? Jagged sand grains of different sizes and the presence of fresh feldspar implies rapid transport and deposition. How fast? Sediment slurries called turbidity currents, known today to travel at speeds up to 70 miles per hour, would have transported and deposited up to 20,000 feet thickness of sand in just a matter of hours. Whew. Talk about rapid deposition, catastrophic processes. That's exactly what we'd expect to find during the flood as described in the Bible. Well, quickly moving on. Evidence number 4, long distance of sediment transport. What evidence do we find? We find the sediment in widespread, rapidly deposited layers had to be eroded from distant source areas and therefore be transported long distances. And fifth, evidence number 5, rapid or no erosion between the rock layers. We find evidence of either rapid erosion or flat, featureless, knife-edge boundaries between most rock layers. Well, I'll unpack this so you can understand the significance of these descriptions. First of all, long sediment distance, transport distance. The source of the pure sand in the Coconino Sandstone had to be far distant to the northeast and to the east because it couldn't have been eroded from the underlying Hermit Formation. The underlying rock layer is made up of siltstone and shale. It's totally different material to the sand in the Coconino Sandstone. And everywhere we find the Coconino Sandstone, we find the Hermit Formation underneath. Here the two are. The sand could not be eroded from this clay and silt underneath. So the source of the sand had to be from a far distance, from the northeast. In fact, it's been estimated to have come from the Appalachians, as far as the Appalachians, right across the continents. Higher up in the sequence, above the walls of the Grand Canyon, we have another rock layer, the Navajo Sandstone in southern Utah. You're familiar with it, in Zion National Park. It makes up the cliffs there. The quartz grains in that sandstone also probably came from the Appalachians of Pennsylvania and New York. That is, right across the continent. Here's the Navajo Sandstone in Zion National Park, up to 2,000 feet thick. And the evidence indicates that the sand for these sandstone layers was transported right across the continent. In fact, water current direction indicators in the rock layers making up the walls of the Grand Canyon, and the same rock layers in other parts of the world, the geologists call them the Paleozoic, that's just a name for those bundle of rock layers, demonstrate that the ocean waters consistently move from northeast to southwest across North and South America. That's right. We can study these fossilized direction indicators with these arrows, like ripple marks and the crossbeds in the Coconino Sandstone. And you imagine that, the water currents were moving right across the North American continent from northeast to southwest. The same on the South American continent, northeast to southwest. And we go to other continents. We find in Asia, Africa, Australia, Europe, the water currents were all moving from northeast to southwest, all the way around the globe, on every continent. Isn't that what you expect by global tides and global tsunamis moving water all the way around, covering all the continents at the same time, because all the high hills under the whole of the heaven were covered with water? That's exactly what we'd expect to find in the flood. What about evidence number 5? Rapid or no erosion between the layers. We'd expect to find evidence where the underlying rock layers had been rapidly eroded off, just eroded off very rapidly and extensively. For example, at the base of the Topeka Sandstone. We saw that just a few moments ago. Okay, here's the Topeka Sandstone at the bottom of the Grand Canyon. Here we can see that erosion surface. And that erosion surface, by the way, is not only all the way through the Grand Canyon, we can see it all the way across North America, we can see it all the way around the world. Even the evolutionary geologists recognise this erosion surface at this level in the rock layers all the way around the globe. That would have marked the beginning of the flood, when everything else previously there in the pre-flood world would have been eroded off. And just to show you the speed of that erosion, at the base of the Topeka Sandstone we find boulders like these ones here. These are small. You can see the hand there for size comparison. Some of these boulders in the Topeka Sandstone have been measured at the size of cars and houses. And large boulders like that require fast-moving water to carry them. So we see evidence where the underlying rock layers have been eroded off extensively, even right around the globe. But we also see where there's been rapid erosion locally, such as at the base of the Temple Butte Limestone. Well, here we can see in the Grand Canyon, the Temple Butte lies below the Red Wall Limestone. And here in a few locations, we can see these erosion holes. That's right. As deposition of the Moab limestone finished there at the bottom, erosion, the waters eroded these holes into which the Temple Butte limestone was deposited, and then the Red Wall limestone was deposited on top of that, all in a rapid succession. Or we find evidence where there's no erosion, which is the norm. We just find evidence of flat, featureless knife-edge boundaries indicating continuous deposition. So, for example, at the base of the Coconino Sandstone, we saw that before. See that erosion surface, that boundary there between the Coconino and the Hermit? I've arrowed it there, you can see it. Where's the evidence of millions of years of erosion? The geologists claim there's 5 to 10 million years of missing time and materials at that boundary. They say that because elsewhere there's another rock layer between the Hermit and the Coconino, and they say that took millions of years to be deposited. But what would happen if the Hermit was exposed for 5 to 10 million years? You'd get gullies eroded into it. You'd get all sorts of topographical features. Perfectly smooth boundary. Indicates the Hermit was rapidly deposited, then the Coconino immediately rapid on top of it. So the layers were rapidly deposited, and there's no millions of years between the layers. They were rapidly deposited one after the other, not millions of years. Well, finally, what about rapid succession of rock layers? Evidence number 6. We find evidence of folding of whole rock layer sequences without fracturing, and we find evidence of polystrate fossils. That is, fossils which required multiple rock layers to bury them. Let's look at this in more detail. Okay, let's first of all focus on folding of whole rock layer sequences without fracturing. Ever tried to bend hard rock, solid rock? It's brittle, isn't it? Limestone is like man-made concrete. Man-made concrete is man-made rock. Okay, you've got sand and water, cement, gravel, and you mix it all up. When the water dries out, the cement binds all the grains together. You try breaking the sand, concrete. It'll break. It's brittle when it's hard. So when can you shape concrete? When it's wet, before it's dried out, before the cement has bonded all the grains together. Well, it's the same with solid rock. Think of these rock layers here in the Grand Canyon. We have the Moab limestone and the Temple Butte limestone. By the way, you can see me there for scale. See that figure with the blue shirt on? That's me for scale. See that boundary just above my head where you've got the reddish, brown-looking Temple Butte limestone underneath the greyish, lighter Moab limestone? See how smooth that boundary is? You can see where the layers have been bent. But do you realise there's 140 million years missing at that boundary? Don't you think after 140 million years, the Moab limestone would have been already hard? And there would already have been erosion features at that boundary? There's no evidence for 140 million years there. The two layers were bent while they were still soft. They were deposited one after the other before they could harden. They were bent like that. Or look at this example in another part of the Grand Canyon. This is the Topeka Sandstone. It's been bent through 90 degrees. You can see the scale there because you can see the people for scale there in the photograph. Now, they say that the Peaks Sandstone was deposited 520 million years ago, but the layer wasn't folded until 70 million years ago. That is 450 million years later. And in that time, other layers were stacked up on top of it, including limestone layers. The whole sequence of rock layers making up the walls of the Grand Canyon were bent hundreds of millions of years after they were supposedly deposited. How could the whole 300 million year sequence be bent without significant fracturing? It could only have been bent when it was soft, very soon after it was deposited while it was still wet, before it had dried out and all the grains cemented together. And that's exactly what we'd expect to find during the flood. These layers were deposited rapidly during the flood. They were wet. The rock layers got bent. The waters drained away, the rock layers dried out and became hard afterwards. So in other words, we see the whole rock layer sequence is deposited in succession, and therefore the hundreds of millions of years never happened. So that's folding of whole rock layer sequences, and then polystrate fossils, our last example. That is fossils which required multiple rock layers to bury them. Here's an example from Australia. You can see on the bottom there, one coal layer, and at the top of the photograph, another coal layer. In between is volcanic ash beds. You can see on the bottom coal bed, you see these upright fossilised tree stumps without any roots, so they didn't grow there, and they're pine trees that couldn't have grown in swamps. And many of these tree stumps went all the way from the bottom coal bed when they were found, went all the way from the bottom of the coal bed right through the top coal bed. So that means the whole layer, all these layers had to be deposited before these trees could have rotted. So the coal bed at the top had to form very rapidly, not over thousands and thousands of years in a swamp. Well, let's go to Joggins, Nova Scotia in eastern Canada. We find these similar upright fossilised tree stumps. In fact, we find these upright fossilised tree stumps penetrating 20 geological horizons, scattered through 2,500 feet of rock layers. So therefore, the 2,500 feet of layers had to be deposited rapidly before the trees rotted. Well, that was just a quick survey of those 6 easy-to-remember evidences. But as we close, let's ask the question, does all this really matter anyway? Is this just a scientific argument? You know, many people say these are just controversial issues and they're divisive. So surely we just need to believe and present the gospel. The gospel is the message that we present. These other issues are just side issues. They're just controversial and divisive. No. Jesus said, "For had ye believed Moses, you would have believed me, for he wrote of me. But if you believe not his writings, how shall you believe my words?" Genesis was the first of the books of Moses. Jesus said, if you don't believe what Moses wrote about creation, about the fall, about the flood, about the Tower of Babel, you're not going to believe my words. You see, when we take it as literal history back there in Genesis, we find out that there was no nephesh death, that is, living creatures that died or shed their blood prior to the fall. Why do we know that? Because we read that God saw everything that he'd made, and behold, it was very good. How does God measure goodness? Jesus tells us, there is none good but one, that is God. So God's standard for goodness is his holy character. So were animals ripping one another apart in the Garden of Eden? No. God said, behold, I have given you every herb-bearing seed and every tree in which there is fruit for meat. That was the command given to all the animals, and to man, they were only plant eaters. There was no living creatures that perished. There was no blood shed at all in God's perfect world. And yet we read in Romans chapter 8 that the whole of the creation was affected by the fall. That is, the creature was made subject to vanity, not willing, but by reason of whom have subjected the same in hope, because the creature itself also shall be delivered from the bondage of corruption into the glorious liberty of the children of God. For we know the whole creation groaneth and travaileth in pain together until now. So no death before the fall, death only after the fall. So what's the implications? If there was no death of nephesh-bearing creatures before the fall, then there could have been no fossils formed before the fall, and thus no fossils in the ground prior to the creation of Adam and Eve and the fall. So Adam and Eve weren't walking on a fossil graveyard in the Garden of Eden. Otherwise, God said to Adam and Eve, if you eat of the fruit of that tree, you will surely die. Adam would have said, look at all these dead creatures in the ground already, buried. No. It was a good world, and it was a perfect world in which there was no death and bloodshed. That only came after the fall. So, evolutionary geology says, though, that there were countless fossils buried in rock layers which formed over more than 500 million years before man supposedly evolved. They say that all these dead things were buried before man. The Bible says no, man was first, the dead things came later. Whose view is correct? That of God the Creator, who was there, who has told us what he did, confirmed by the testimony of Jesus Christ? Or that of the fallible scientists who are not there? They don't know everything. They make mistakes, but God never tells a lie. You see, if the Bible's account is literally correct, which I believe it is, then most of the fossils formed during the flood, the 1-year global catastrophic event that we've seen the evidence for here today, and that means the 500 plus million years never happened, and the earth therefore is very young. Well, enjoy that. A lot to comprehend, but we've made it easy for you because this has been recorded already in that DVD, Rock Strata Fossils and the Flood. And in fact, these evidences are presented in this pocket guide to the global flood. Easy to understand evidences with the pictures there in that easy to read pocket guide. If you're interested in the formation of coal and oil, there's another DVD where I talk about the recent rapid formation of coal and oil. Or the flood, the mechanism for the flood. Or the Grand Canyon. In fact, there's a whole series of DVDs that deal with a number of other issues like radioactive dating and radio halos that are packaged in this 5 DVD set, a biblical view on the age of the Earth. If you want to go into more details, there's my 2-volume book, Earth's Catastrophic Past, 1,100 pages in 2 volumes. It's easy to understand, little short bites, but it's very comprehensive in defending the biblical account of creation and the flood and dealing with the geological evidences. And don't forget our Answers magazine, which is actually 2 magazines in one. There's a family magazine, and then there's the kids magazine as well. And you can also get it digitally, so you can have on multiple devices. And our website is always a go-to place. We have our Answers Research Journal, where all these details are backed up with technical papers that are freely available, downloadable from our website with PDF files that you can save and send to anywhere around the world. I need to remind you today that while the museum and the Ark are closed due to the coronavirus, there's free shipping on orders of $50 or more. And also, while the Ark and museum are closed, we have our creation apologetics classes that are available at a dirt cheap price. And don't forget, during this lockdown period, we need your donations to sustain the Answers in Genesis ministry. Any amount will really help the ministry. And don't forget, just like this program is live here from the Legacy Hall and the Creation Museum, we have other live programs. The schedule is there, and it's online for you to see. And we've just announced the launch of our Answers.tv, our live streaming platform, where all these DVDs and presentations are available for you to download and view at any time, any place. In fact, it can be seen all around the world. That's right, Answers TV. In fact, you can start with a free weekly trial anywhere around the world, no matter where you live. As long as you've got access to the internet, you can live stream all of our video content. Over 1,000 are now up there on the website of our programs, and more are going up daily. And at only $39.99 a year, it's a steal. That's less than $4 a month. And coming in the summer, we'll be able to also stream from various devices so that you can use the Answers TV app on a number of devices, streaming to them so that you can look at our content any place, anywhere, anytime. Well, thank you, and enjoy the rest of your day.